So welcome to Everyday Mathematics. We are going to look at problem 13 of the MIT Integration Big File Exam 2016, which is the indefinite integral of sine x times cosine of sine x times cosine x. This is an indefinite integral. It looks quite messy, but it's actually a very simple problem. And we'll see two methods which we can use to solve this problem. There are probably other methods one could employ, but we're going to dwell on majorly two methods for this problem. So this is our problem, right? Sine of sine x, cosine of sine x, and cosine x, right? Let's look at method one. Okay, so suppose you had a function f of g of h of x, right? And you're trying to differentiate this function with respect to x. So the easiest way to do this is, let's assume we just abbreviate x, and we're going to differentiate f with respect to g, and then we're going to differentiate g with respect to h, and then we're going to differentiate h with respect to x. This is how you would be able to differentiate it. And looking at our problem here, this is exactly what is happening, right? Our dhx here corresponds to cosine x. Therefore, our hx is integrating cosine x is going to be sine x, right? And then the next thing is, let's write this problem once again. And then we said we had df, dg, dg, dh, dh, dx. And we already found h to be equal to cosine to sine x rather. So let's just okay, now what about g, right? So g is just going to be equal to sine of sine x, okay? And f, since g and f seem to be almost the same function, we're going to see that in fact what we can do, we can say that let's rewrite this a little bit in a more concise way. Sine cosine of sine of x cosine of x is equals to the integral of sine of x times the derivative of sine of sine of x, right? Which means that the entire problem is just the derivative of half of sine squared sine x integral, right? So that when you differentiate this, then you have this second nested part, right? So our problem has become the integral of the derivative of a half of sine squared sine x, which means it's equal to a half of sine squared of sine x plus c. So that's the fast way of dealing it, and it's a little bit abstract, but that's how I would quickly integrate it. Let's look at method 2, and this is the more conventional way that maybe one might choose to use. Okay. So I would say I want to substitute off this. I would say let u be equal to sine x, and so du dx is equals to cosine x, and therefore I would want to substitute cosine x dx with du. So this part here will later be substituted off. So our problem now, sine of sine x cosine of sine x cosine x dx is the same as sine u cosine u and du. Okay. So which is the same as since sine of 2x is equals to 2 sine x cosine x, using this relationship in terms of du we have a problem that is of the integral of half sine 2u. So since we have a problem that is sine 2u du, that means that our integral is a quarter cosine 2u plus c. But wait a minute, we said u be equal to sine x, so our integral is a quarter cosine 2 sine x. But you may want to say, okay, well, the answer we've gotten here is different from what we got with the first method. So we have sine x cosine sine of x and cosine of x being equal to negative a quarter cosine of 2 sine x plus c. So this is a little bit different. We know that cosine 2x is equals to 1 minus 2 sine squared x, right? Which means that our problem now becomes a quarter. Cosine 2x now becomes 1 minus 2 sine squared. In bracket here we have sine x, and we have c. Since we have negative a quarter, 1 minus 2 sine squared sine x plus c, which is equals to negative a quarter plus this 2 times negative a quarter becomes a half sine squared plus c. We see this constant and this constant interact to get a new arbitrary constant, so we have a half sine x plus a new arbitrary constant. So we realize that this answer here is the same as what we obtained using the first method, and that is how you'd be able to solve it with the two methods. So thank you very much. Until next time, bye bye.